All right, chapter 5. We're going to be looking at systems of differential equations. The first thing we do in chapter 5 is we learn that we can take something that's a higher order differential equation and turn it into a system. So this is number 2 out of the book. That's a symbol for fourth derivative, not x to the fourth. Okay, so I guess my first question is, could we solve that equation with what we learned in chapter 2?
Nope. No.
No, why not?
It would have been in chapter 2. Because it's x and a t.
Why can't we solve it? Can't we solve it?
I don't know why we can't. They said no. I asked them why. They didn't give me a good reason.
Because there was 2 choices. There was no or yes, and there were 50-50. Is it because of the cosine t?
No, the cosine 3t is not a problem. The cosine t3 tells us, if you go back to chapter 2, the cosine 3t tells us what we should make for our guess for our particular solution. We would need an a cosine 3t and a b sine 3t. That's correct. Can you solve the homogeneous equation?
Yep. Yeah, it's homogeneous.
How would you solve it? R to the fourth. All right, so the big hang-up would be the characteristic polynomial, r to the fourth plus 6r squared minus 3r plus 1 equals 0. The big hang-up would be, how do you solve that equation? Can you factor it? No, I don't think it factors. Your typical factoring technique for a problem like that would be the grouping method because it has 4 terms.
Find some roots, and then
we could perhaps use our calculator, find some roots, do some division, get it down to a quadratic equation, and eventually solve it. So it's possible that we might be able to do that one in chapter 2, from chapter 2 material. The big question would be, does this have 2 real solutions that we can find on our calculator and use at division? Or are all 4 of these solutions complex? In which case our calculator would not do us any good. The answer is, I don't know.
I just made it up.
But what we're going to do is instead, we're going to convert this into a system of equations. And then we will learn techniques for solving systems of equations. And it turns out the techniques for solving systems of equations quite often are easier than it is to try to factor that 4th degree polynomial.
Are they easier even if it's something like a second degree?
No, if it's a 2nd degree, then we don't have the factoring problems. Right. If it's 2nd degree, we factor it, or if we can't factor it, we use the quadratic formula, and we can find the roots very quickly, very easily. So if it's 2nd degree, absolutely not, you wouldn't want to do this. 2nd degrees are easy to solve as they are. All right, so here's what we're going to do. And we're going to let x1, we're going to call it just x. Okay? And then x2 is going to be x1 prime. What do you think x3 is going to be? It's going to be x2 prime, which is the same as x1 double prime. Pretty clever. So what are we going to have? How many equations are we going to need?
We're going to need like a... Let's get into it. Yeah, we still need 2 more.
Why do you need 2 more?
Because we're going to x 4 to the 4. We're going to do x to the 3rd double prime.
Okay.
X3 double prime.
So x4 is x3 prime, which is x1 triple prime, isn't it? Well, we really don't need an x1 triple prime, do we?
Oh, no.
No, why not?
Because there is no X triple prime.
Because there's really no x triple prime. Okay, but I do think we need it anyway. What's our x5 going to be? x4 prime, which is x1 fourth derivative. Okay, so here's our system of equations. Our system of equations is x2 equals x1 prime, x3 equals x2 prime, x4 equals x3 prime, and then what I want to do is I want to have this x to the fourth all by itself. What's this x to the 4 all by itself? It's x5 is going to equal, I'm going to have cosine 3t, and I'm going to move this 6x double prime over.
Wait, why is X5 equals cosine 3t?
I'm not done yet. I want to get this one by itself, so I want to have them look all the same, x2, x3, x4, x5.
Okay.
So what do I get when I move 6x double prime over? That's minus 6x double prime, but what's x double prime? It's x3, so that's 6x3. Then I'm going to move the 3x prime over, so that's going to be plus 3, what's x prime? x2, minus, I'm going to move the x over, that's x1. Typically, I don't think we would use x5. We would probably call it x4 prime.
So do you just go to the highest x that you have? And then
You go to the highest x that you have, and then you move everything over and substitute it in. Questions on that?
Wait, that's it.
That's it. So the first couple questions in your homework are take a differential equation and convert it into a system of equations. There it is. There's my system.
Wait, how would you put that in a matrix?
How would I put that into a matrix?
Yeah.
We'll get to that.
Okay. Tune in.
If you look in your table of contents, where is it? Section 5.3, matrices and linear systems. So we'll use a matrix method, and then we'll use a method called eigenvalues and eigenvectors. Have you gotten to that in linear algebra yet? All right, so those of you in linear algebra are going to have a big advantage there. All right, well, here's the bulk of this section.
Is it?
Back when you took an algebra class many, many years ago, you learned how to solve systems of equations. What were the different techniques you learned for solving systems of equations?
Substitution.
Substitution,
Elimination.
elimination,
Matrix.
matrix.
That's it.
There's one more, graphing. We're not going to do graphing. In this class, we're going to do substitution, we're going to do elimination, and we're going to do matrix. In section 5.1, you're going to use substitution. So if I give you that system of equations, how are you going to solve that using substitution? Take the derivative of x. Because if I take this equation here, and I take its derivative again, what do I get? X double prime equals y prime, but y prime is the same as x. So I get x double prime equals x. That's the substitution method.
Oh, I see.
How do you solve x double prime equals x?
Does it have to be
Integrate.
solved?
It has to be solved.
Put in y prime for
X double prime minus x equals 0. So now you have two choices. You can solve using what you learned in chapter 2, or you can solve using what you learned in chapter 4.
Chapter 2.
You like chapter 2? Okay. R squared minus 1 equals 0. So R is plus or minus 1. So X is C1 e to the 1t plus C2 e to the negative 1t.
Where are we getting this from? Well, you said earlier in the year, David, we did chapter 2. Yeah, but yeah. It's coming finally.
So this is kind of a nice little thing here in chapter 5. We get kind of a review of what we did in chapter 2. Works out well. So what's y? Y is the derivative of that. So I take the derivative. The derivative of C1 e to the t is C1 e to the t minus C2 e to the negative t. Why minus on that one? Because we got a minus. The derivative of e to the negative t is a minus 1 e to the negative t. All right, let's try another one. How about x prime equals negative y and y prime equals 10x minus 7y. Oh, let's see, this one's got some initial conditions. X at 0 is 2 and y at 0 is negative 7. All right, so how do I use the substitution method on this one? I can't really integrate this because it's got mixed variables over there. Take the derivative of the first one? Okay. So x prime double prime equals negative y prime. And substitute in. So that's negative 10x minus 7y. But that still has x's and y's in it. I can also use this equation and substitute that y is a negative x prime. That's exactly correct. So it's kind of a double substitution sort of deal. Okay, so we're going to have x double prime equals minus 10x, and then I'm going to have minus and a minus, but then I'm going to have another minus from this, so that's 3 minuses. That's minus 7x prime. Now we use the same method as before. X double prime plus 7x prime plus 10x equals 0.
So
R squared
plus 7r
plus 7r plus 10 is 0.
It's not too bad.
Quadratic formula, how about r plus 5, r plus 2? It factors. I don't need to use the quadratic formula. So r equals negative 5 or r equals negative 2. X equals C1 e to the negative 5t plus C2 e to the negative 2t. And then to find y, I need to take the derivative and do a negative on it. All right, so y is 5 C1 e to the negative 5t. Because when I take the derivative, I'm going to have to multiply by a negative 5, but then I've got this other negative, so that makes it a positive. Plus 2c2 e to the negative 2t. Not quite done though, why not? I have initial conditions, so I got to plug those in. So I'm going to have 2 equals C1 plus C2. And then I'm going to have negative 7 equals 5C1 plus 2C2. 2C2. How do you solve that system of equations? Matrix. Oh, matrix. You guys love your matrices. Multiply this one by negative 2. Negative 4 equals negative 2C1 minus 2C2. Negative 7 equals 5C1 plus 2C2. Add those together. Negative 3 equals 3C1, so C1 is negative 1. Take that, plug it in there. C2 has to be 3. You can solve these more quickly by hand than you can grabbing your calculator and working them out. This is my opinion. All right, so it looks like my final answer is x equals negative e to the minus 5t.
George?
Yes?
Yeah. You're submitting negative 11 equals 3C1?
Oh, negative 11? I like negative 3 better.
I like it better, but...
You can't just do that, but you have to correct it.
I got to correct it again. All right, so C1 is negative 11 over 3. So I plug negative 11 over 3 in, add that to the other side. That's,
Negative 5 over 3? Would it be negative 5 over 3? No.
negative 5 over 3? You just messing with me?
How about that, mate?
How about 17 thirds?
Yeah.
That's, I was writing 17. You can see I crossed that. All right.
Use matrix.
You could use a matrix. It takes all the fun out of it. X equals negative 11 thirds e to the minus 5t plus 17 thirds e to the negative 2t. And then y is, I got to multiply this one by 5, so that's negative 55 thirds e to the negative 5t plus 34 thirds e to the negative 2t. Questions on that?
Congratulations.